is Busan, and we're doing fire detection system. Thermal fire detector is a thermocouple is a spot type detector. Spot detector is an individual used for detecting a fire in an engine. How it works is a thermocouple consists of a loop of two dissimilar metals that you see over here, joined together. It produces a voltage when one more of is positive difference from the heat, and then it produces a voltage that you see right there. What are they made of? Thermocouple junctions are made of specific alloys which have a relationship between temperature and voltage. Different alloys are used for specific temperature ranges. Type K thermocouple consists of 90% nickel and 10% chroma, is most commonly used in aviation. Type E is chroma, and constantine is a non-magnetic high output thermocouple. Where they're used, they're used in engine. Can you change the PowerPoint? So they're used over here, as you see. They're used on this one over here. There's fire detectors over here, and when you see a difference in temperature, they'll heat up and they'll indicate in the cockpit. In a typical thermocouple system in an aircraft, active thermocouples are placed in fire zones around the engine, while a separate thermocouple is placed in the dead area as a reference thermocouple between insulated blocks. Okay, and you have the active thermocouples over here, and then you have the test switch over here with the reference thermocouple, and then you have a slave relay with a warning light, so you can test the thermocouple to see if it's active or not. And when a fire occurs, the temperature around the active thermocouples rises much faster than the reference over here. So these ones rise higher than the one over here, and then the difference between them produces a correct in thermocouple circuit actuating the light in the cockpit. So when you see a difference in temperature between active and reference, you'll see the difference over there, you'll see in the cockpit. Okay.
Sure, and today I'm going to talk about the pneumatic continuous loop type system fire detector. This is a continuous loop fire detector with a single switch in a formal Iconel tube. This detector is used instead of several individual switches like the spot detector. This right here is the actual detector unit, the sensor, and this part right here is where the switch is located. You can see it right here. This is the switch case chamber. Okay. The operational principles of this sensor is based on the Gauss law. So the sensing element is a sealed tube that contains a special core material as helium as inert gas. Sorry. The sensing element has one end closed and the other connected to the switch case. So basically right here, inside this, it looks like a wire, but it's a tube. It's an Iconel tube. Inside here, there is helium, which in case of a fire, it will expand and it will close a switch inside the switch case, which is right here. This switch case will send a signal to the cockpit and will turn on a light, and it will let know the pilot that there is a fire on the engine compartment. What I said before, in a fire event when the temperature in the engine compartment increases to a preset level, this is set it to a preset level. The pressure of the gas inside the sensing element close the pressure switch, which is the switch I already said is inside here, and will activate the warning at the cockpit. Right here we have the number one detector. It's right here. Number one fire detector. It's right here. There's another one right there. This detector will, in case of a fire, it will send a signal through to the engine control panel. It would advise the pilot, would let know the pilot that there is a fire in the engine compartment. Can you please change the another picture? Thank you. Right here is the actual diagram of how this sensor will be wired around the engine compartment. This is how they wired the tube around the engine compartment. This is the actual switch case. And in this case, this sensor was actually used in a helicopter engine compartment. Thanks a lot for your attention and hope you enjoyed the
demonstration about how the thermocouple works. Right now I'm going to light this over here, and then over there you're going to see in millivolts, right?
You're going to see a reading over there. It's going to be very small, but it's because we have to heat the probe for a long time to get the higher reading.
So here we go. You see it?
Sure. Hold on a second. Keep on going. And the tip. It's there. You see it? Multimeter. Check the multimeter. 48.
48.
0.0048 volts.
So as you keep on lighting the tip, the harder it gets, the higher the voltage.
And now it's going down.
Now it's going down because it's cooling.
Yeah.
So usually
You'll see thermocouples on the exhaust section of engines, and see, these are all the engines. Yeah. And that's about it. Hope you enjoyed.